in order to understand reflections, we need to know a little bit about straight lines. On this set of axes, we have the line here, which is x equals 2. The reason we call it the line x equals 2 is because every single point on this line has x coordinate equal to 2. And this line is the line y is equal to 3, because every one of the y coordinates on the line is 3 up, which basically means that every one of the y coordinates on the line is y equals 3. If we look at these lines here, so this line, which is going through the origin and going straight up, this is the line y is equal to x. Let's remove these other lines. This is the line y equals x, because if I pick any point on this line, the x coordinate is the same as the y coordinate. For example, at this point, we have x is equal to 2 and y is equal to 2. This other line, which goes through the origin and slopes downwards, is the line y equals minus x, because whatever the x coordinate is at a point, so if I choose this point here, the x coordinate is minus 6 and the y coordinate is plus 6. So we can see y is equal to minus whatever the x is. So that's the line y equals minus x. So we have y equals x and y equals minus x. We're now ready to have a go at some questions. For example, if I want to reflect the shape B in the line y equals minus x, the first thing I need to do is draw the line y equals minus x, which I'm going to do, well, which we would do with a ruler. So I'm going to draw a straight line through the origin, like this, and it needs to basically be equidistant from the x and y axes. So this is my line y is equal to minus x. Let's make it a little bit bigger. So that is my line y equals minus x. And what I would like to do is reflect shape B in this line. To reflect shape B in this line, I need to consider the coordinates of the corners of the shape. So this is the shape B. If I look at the corners, this point here is at across 4, up 3. So if I want to reflect it, the reflected point is going to be at minus 4, minus 3. This point here is at 4, 8, so the reflected point is going to be at minus 4, minus 8. This point here is at, and the other corner is at 9, 3, so we need to go to minus 9, minus 3. If I then join up these points, I will have reflected the shape B. Another way of thinking about this is that to get to this point, so to get to the point here, to get to this point, 4, 3, I've gone from 0, I've gone to the right by 4 and up by 3. So to get to the reflected point, I go to the left by 4 and down by 3. And it's the same with the other points. Here is a question for you to try. So if you could, on squared paper, draw the axes and draw the line y equals x, I'd then like you to reflect the shape C, which is this triangle here. So this triangle here, I'd like you to reflect that shape in the line y equals x. Pause the video now, and when you're ready to go to the answer, press play. To do this question, I'm first going to draw the line y equals x. So let's make that a bit thinner. So I'm first going to draw the line y equals x. So it's going to go through, it's a straight line to the origin, and it is at 45 degrees to the, it's 45 degrees above the x-axis, like that. Let me just make that a little bit bigger. Like that. Okay, I'm now going to consider the coordinates of the corners. So to get to this point here, this is at minus 5, 8, right? So to get to this point, I've gone left 5, up 8. So I need to go to the right by 5 and then down by 8. To get to this point, I've gone minus 10, 3. So I need to go to the right by 10 and down by 3. And finally, this point here, I've gone left 10, up 8. So I need to go right 10 and then down 8. And we can see that the way to think about it is, if you folded along the reflection line or the mirror line, then the reflected shape would be the imprint of the original shape. So now we join up the corners with a ruler, and that is our reflected shape.